All right, welcome everybody. Welcome. So this is the Khronos and PCGA co-hosted press conference. Wanted to just thank everybody for coming. Know that there's a lot of different events going on, and we really appreciate you coming here to this event. My name is Eric Narecki. I'm the Khronos Vice President of Business Development and also the PCGA Executive Director. The agenda for today is we're going to start off with, well, after I say a few opening words here, I have Matt Ployar from the PCGA. He's the president of the PCGA and from Intel, going to give us some opening remarks. Ted Pollock from John Petty Research is going to give us an overview of the hardware market as it pertains to the PC gaming market. We're going to have David Cole, information from DFC. Matt Ployar is going to be presenting that. Question and answer with about the research, so that after you've gotten an introduction and have the information about the research, you get to ask some questions of these guys. They, I have to say that I took part of the member briefing today. The information is fantastic, and these guys really know what they're talking about. After that, we move on with Khronos, where we're going to have the Khronos president, Neil Trevitt from NVIDIA, speak on Colada news and WebGL news. We'll have Rich Geldrich of Valve giving us a quick look on OpenGL on Linux. And finally, we'll have a WebGL demo on mobile. And take a look at how HTML is blurring the definition between what's mobile and what's not mobile. How all these platforms are going to work together and pretty much seamless applications. So with that, let's go ahead and get started. Matt?
Well, thanks, Eric. Thanks everybody for making the trek over here. I appreciate you taking the time to listen to what we're going to be talking about. We're going to kind of cover a bunch of highlights real quick. Might have some, we're going to do a quick Q&A, so I kind of want to go through some of the key highlights of the data from the findings, if you will, from the research. And I'll probably do a kind of a messy transition, but I want to show you some of the meat, heart and soul, if you will, of some of that research, so you guys can actually kind of take a look at what we get to see. It's just really a kind of a tip of the iceberg look. But you know, there's a lot going on in the industry, and we want to really kind of be a little bit more vocal about what's happening, because there's a lot of misunderstandings, or messy definitions, or a lot of weird things kind of going on. So I want to kind of walk people through what that looks like. So just to provide maybe a little bit more context as well. So this actually not my deck. So it always happens. One of the things that's taking place is, there's a lot taking place in the ecosystem in terms of all these mobile devices kind of coming along, and people don't know exactly where to kind of draw the line on things. So again, we're going to kind of walk you through that real quick. So with that, so one of the things I kind of like to lead off on is like kind of what's going on in the marketplace, right? So the pictures are intentional, but there's kind of these tectonic shifts going on. These different, as I walk people through that, the definitions of PCs are kind of rapidly changing and evolving. From an Intel perspective, putting my Intel hat back on, we don't care what the form factor looks like. I did an Ultrabook presentation earlier. As long as Intel's stake or skin in the game is, as long as it's running a Core i5 or an i7 processor, we're really happy, kind of stuff, right? So the pictures show these transformable and hybrid-based kind of platforms, as well as the all-in-one form factor. But where do you draw the line? When does it stop being the sort of Android device, and when does it kind of start being a PC, or what is it able to play these games or run these other software applications in an x86 environment? So again, the definitions are changing rapidly. There's also kind of a big movement towards this multi-device gaming situation. And what's taking place is you've got people like Sony buying Gaikai, acquiring them, and they're looking at extending the gaming experience across all these different screens. I'm former Microsoft, so I'm very well versed with what we used to call back then as 3 screens. Now it's the multi-screen thing. You're going to just see that become more ubiquitous over time, and between the other technologies with streaming and cloud paging and the game engines are getting better. You're just seeing the extension of your game going again to all these screens. That's kind of what the picture's trying to convey there. One of the other big kind of things going on, open platform directions. So I don't know how much you guys keep track of the Game Developer Conference. They do these big surveys every year, and they hear all the developers, hey, what are you here for? And top of mind was tablet form factors. Number 2 was smartphones. Number 3 was the Valve Steam box. So got kind of some interesting things. This is a new thing, kind of that's occurring. There's a lot of interest taking place. As you go down the stack of developer interest, you get other consoles and then handheld devices on the other end of the spectrum. So I just find that to be kind of interesting. This is new, and it shouldn't be, I would say, underestimated. The 4th big thing, business models are fracturing. I don't want to say that, I don't want to overplay this. We all know about free to play. We all know about things like game cards in a Target or Best Buy or whatever. I was actually at a Best Buy a few days ago, and I'm like secretly taking a picture of all these game cards, and I'm like, it's interesting. You don't really think about it, but this is global, and it impacts the ability of how people are getting their content out there and how are they monetizing off of it. One of the things I like to talk about in a big way is like the free-to-play stuff. You look at like the League of Legends games or the World of Tanks, they've technically sold 0 units, but they're making a heck of a lot of money because they're not measuring units, they're measuring reserves. There's a big difference. Right now, we're moving towards a world where 80% of PC shipments are mobile. Tablets or convertibles or hybrids, ultrabooks, ultra-thins, they're mobile. And that is impacting game development in a big way. It impacts how the graphics APIs have to address these shifts and these changes. And it kind of all ties in with this kind of multi-device and screen direction of what's going on. So that is my lead-in. Earlier today during our PCGA kind of workshop summit that we were doing, we actually physically had David Cole here. So I'm going to channel him as I kind of segue into some of the other slides. But before I do that, we first get Ted. I think we have his deck in here somewhere, hopefully. Why don't you pull that up? Ted's going to be representing John Petty today, who is ill, unfortunately. Apologizes that he couldn't make it.
While we're getting that up, I'll just introduce myself quick. I'm a research analyst. I work at John Petty Research, and I cover the global gaming sector with a bit of a specialty in the PC space. So that's part of the reason I'm here today. So a bit about John Petty Research. JPR has been following the graphics industry for about 20 years and really focused on anything around graphics or design software, gaming, workstations, semiconductors. John likes to say anything about the pixel he's interested in, and that's what the company is focused on. So JPR is in a number of different sectors of research. Gaming PCs are mostly concentrated in Asia Pacific. There's a pretty simple reason for this. The console market, it doesn't really exist in China. And so PC gaming is extremely strong there on low level and on high level. There's everything from people playing on low-end PCs at home to the cafe, internet cafe phenomenon to $3,000 computers being built in a DIY type scenario to companies like Alienware having actual stores, almost like an Apple store in China. The average age gamer is about 35 years old on the PC, and I think one of the challenges that, that the industry is working toward is to try to lower that, to get some of the youngsters to understand that their PCs they use for their schoolwork and at home are actually very robust platforms for interactive entertainment. And thanks to the advances in integrated CPU graphics, the price to drive a 1080 display at a decent frame rate has dropped significantly, and you can get a great experience for $600–700.
Do you have historic data about that average age? Because I mean, PC users have usually been older. Is it getting older or staying about the same? Or?
Yeah. Because of the mobile device phenomenon and because of the just enough computing phenomenon, that includes things that we're trying to nail down the definition of a PC, as Matt was going over. Is a Chromebook a PC? You know, so what's going on is that that Windows gaming age is probably getting a little bit higher, which is obviously a trend that the PC gaming industry wants to try to reverse and advertise to younger people and to get them playing on the PC. But it's not anything to raise alarms about at this point. This is the distribution of the different PCs as far as the level of graphic semiconductors and CPU power. About 30 million of the ultra high end, 220 million performance and mainstream, 350 million casual and web capable PCs. Now these numbers shift a bit based on the assumed refresh rate, or when someone, the rate at which someone buys a new PC, which could be 3 to 5 years, somewhere in that range, or 2 to 5 years. One thing I think is interesting about this distribution is that while you have these definitions of enthusiast, performance, mainstream labeled for the hardware components, there's actually hardcore gamers and casual gamers within each of these segments. So you'll have someone with a $4,500 liquid-cooled monster who also plays casual games, to someone running Falcon 4.0 with an old Microsoft twist stick down on the bottom. So it's kind of cool. It covers all the different areas. This is a chart comparing units sold to dollar sales for graphics cards, essentially, or AIBs, which stand for add-in board, as JPR defines it. An interesting data point is that you see that Enthusiast is a tiny slice from a unit sales perspective, but significant percentage of sales for a dollar perspective. And things like the NVIDIA Titan at $1,000 a card help that situation. But even more amazing is that when you take the entire computer, not just the graphics card, that Enthusiast number jumps to about 1/3 of the entire hardware sales, because people who buy expensive graphics cards buy expensive power supplies, they buy expensive cooling solutions, lights, SSDs, all the different components you can imagine. In addition to laptops that have not exactly the same phenomenon, because you don't construct the components, but the laptops that have enthusiast level GPUs are quite expensive. This is the installed base of gaming capable PCs globally, and there's a lot of them out there. And this is really the big opportunity for the PC gaming market to take advantage of a user base that's not everyone's playing games on their PC. So if you educate people about the capabilities of the PC, there's a huge market opportunity out there. And this is especially helped by what I was saying earlier, that the entry-level hardware capabilities of a $500–600 PC these days can run 60 frames a second at 1080 on a lot of really nice games. So it's a huge opportunity. My email is ted@johnpetty.com. John is John at johnpetty.com. And we'd be happy to answer any questions that you might have. Feel free to email me. I have some cards on me as well. Thank you.
What I'm going to do is kind of do a quick run through because I want to open up for Q&A. Actually, before I move on to that, so the hardware Pinnacle report that we've done and working with John and Ted here is just honestly the tip of the iceberg, right? We obviously, for our members, provide a lot more data, so we're going to walk through some of the key findings. But on the software side, I'm going to channel David Cole real quick. So these are the kind of the big three things that we're kind of queuing in on. And in short, the big news for this year, I want to kind of keep it simple. The big three stories are, one, we're at 20 billion now in the PC gaming industry. That is across all your different segments, demographics, and geographies, up and down the stack. So, you know, a lot of that is driven by the free-to-play microtransactions, subscriptions-based revenues, all of your game cards, for example, it's the full meal deal. This is now, they perform better than any other single gaming platform, and what that means is a lot of other platforms have to kind of, you know, you got to add 3 consoles together to get even close to $20 billion. So this is doing it by itself, and it's a global phenomenon. You can't just look at, say, North America and Europe and call it good. So 20 billion is big news. That's keeps growing. It's healthy. Number 2, so the way that David Cole articulates the size of the TAM, or the total available market, is he's looking at now a little over 1 billion consumers that you could actually reach. If you shipped a game that, you know, you wanted to reach this many consumers, there's obviously more than 1 billion consumers out there on PCs, but you have to kind of subtract out, only so many people are going to play games. There's only going to be able to say 50% of the population or whatever that's out, made out to be. But the way that he is slicing and dicing this is 1 billion. And I've got other graphs on the left-hand side there. You can't see them, and I could blow them up a little bit later for the Q&A. But the idea is you can show what the sizing of those markets are, the demographics on a per geo basis across this, you know, globally, if you will. The third big point that he wants to make is over 6 companies made over $1 billion in the PC space. That's pretty big. That's very healthy. Just 6 companies alone. It's obviously a lot bigger. So when you add all of that plus all what everyone else is making, that comes to that 20 billion number. So very healthy. And then it kind of ties in with the last point that he wants to make there, that he wanted me to share with all of you, which is he's telling people to, you know, don't get into that herd mentality. Don't just stop making games for PC or console and then go towards mobile. He thinks that's very misguided, quote unquote. And he really believes that what you should do is look at the mobile space as a way to extend your game, your IP franchise. Use mobile as a way to just, you know, extend that experience. Don't just do either or, right? So that's really kind of David's big 3 points that I'm going to share with you. Again, we're kind of running out of time, and I do want to actually hear from you folks real quickly on the Q&A. Ted will help me out with that. So, so there's that. So let's go ahead and open it up for questions. I think we're at 6:45-ish right now. Yes. Yep. 6:45. Okay. Questions. Again, tip of the iceberg. I don't want to kill you with 50 slides worth of data, but
just to clarify,
sure.
20 billion revenue from sales of games. That's not
PC games.
PC games
only.
That's not including and boards hardware.
That's correct.
Exactly. The hardware business is another 20
Right, okay.
plus
So
billion.
software.
Exactly.
Yeah. And add-in stuff, microtransactions.
Oh, right, plus contracts.
Questions?
You were talking about the mobile devices. Are you also discussing the living room experience, or where the consoles might have precedence at this point?
It's not, you know, from a research perspective, it's not really covered in the Pinnacle reports. It's more of a strategic outlook thing that we're looking at. I think right now everyone's got their own theories on where that's going and, you know, how you extend. You know, obviously there's the Steam box is getting a lot of attention here at GDC, for example. Obviously with my Intel hat back on, we're looking at that obviously very closely. But you know, there's a lot taking place in that space. You know, you're seeing kind of a shift. A lot of people are I think a better way of saying it maybe is, different things are grabbing mind share, or time share, however you want to look at it, and even dollar share, away from consoles and living room. It could be tablets, it could be smartphone market or whatever. People just want to take their games with them wherever they go. And it kind of ties into that earlier data point. But it's about 80% of all devices now, PCs are shipping, are mobile form factors. So that's big. And people are looking at, like I myself, I take an HDMI cable, plug it in onto my TV or my big screen in my den, and I'm gaming. I love it. But I take it with me, right? I'm playing games everywhere I go. So. But it's, yeah, in the report, Pinnacle report itself, we don't do a, I would say, user-based study. You're in the iCafe, you're in the living room, you're in the bedroom. We don't go into that level of detail.
What about the dynamics of PC development? Is it getting stronger in marketing terms, or is it slowing down?
For PC?
So what's in the near future? What's in a year or two? What can we expect?
In the software side of the
the software, mostly about games.
Let's see, I think David was showing about, what, 8% CAGR right now for PC games, what he talked about earlier. It's healthy. He's seeing more of an uptick in growth in geographies like Russia, for example, is just going gangbusters. We kind of expect to see that also occur in other like Latin American geographies like Brazil or whatever. Anytime you go to Europe, it's like a GDC or Gamescom, it's big over there. So there's a bigger focus typically for PC games development in these other geographies. And of course, APAC is almost 50% of the global picture in terms of PC games development.
I would add one more thing onto that. The popularity of the digital distribution platforms like Steam, Origin, and Uplay are giving publishers, hopefully, I believe, more confidence in the platform and controlling their products in the market, and you know the fears of piracy. So I feel very bullish about developers embracing the platform.
What about video game sales number? Let's say we take some blockbuster, which is multi-platform. Sales on consoles historically have been much larger, like maybe 10 larger than on PC. What's the situation now with all that digital distribution?
That's one of David Cole's favorite data points. So he's been also doing this for well over 20 years plus or whatever, and started tracking markets that weren't historically tracked really well. One of the things that, you know, I've got friends and even been on advisory panels for other companies that track this data. Retail for PC gaming is about 1/20th of the market. It's a rounding error.
Oh, good.
It went digital a long time ago. So if you look, the way I like to articulate it is, if it's a tree falling in the forest, it's got very little to fall before it's at zero, right? There's like 20 or 30 million units roughly globally. But when you look at all, like League of Legends, 70 million, over 70 million registered users, 30 million monthly active users, 12 million daily active users. Your conversion and attach rates keep going up and up and up year over year. Game cards, most of that's not tracked in the traditional, you just can't go up to VG charts online or get it out of NPD, right? So David is very big on making sure that that this crowd and everybody else in the world understands that, hey, you know what? When you look at the console versus the PC, and I don't like to pit them against each other, you're missing out on so much of the market if you just look at retail. You just are. Right? So, like most of the story. Okay. For time's sake and for everybody here, I really do want to be mindful of keeping things on track. I'm going to go ahead and open it up and make the transition over here. I think you're going to do the...
Right. Thank you, Matt.
Yeah. Thanks, everybody.
Thank you, Ted. Next up, we have Neil Trevitt from NVIDIA, president of Khronos.
Hey everyone, it's good to see so many people here. We're really happy to share this event with PCGA, so thank you Matt for great cooperation here. There's a lot of synergy between what the two organizations are doing. We actually have some press releases. The press releases are going out tomorrow morning. It's two announcements that are actually related, and hopefully you'll find them interesting. We'll just take a couple of minutes to review them, and then we're going to hand over to Rich from Valve, who's going to be much more interesting. So we're building the ecosystem continuously for 3D gaming and other applications too. We actually have two announcements. One, Colada. We're actually building out Colada to be the most reliable 3D asset interchange format in the industry. I'll give you more details in a second. We also have some pretty interesting announcements around WebGL, which is bringing 3D graphics to HTML5 and the web. And we're gradually, but surely, building WebGL into the most robust and secure and portable 3D platform in the industry. And the related, the thing that actually links the two together, we're announcing we have a new initiative called GLTF, OpenGL Transmission Format, which is a runtime, highly optimal, JSON-based format for sending assets across the network from a server to a client. And we're doing a lot of work in open source to make that come alive. I'll give you a little more detail on that as well. So let's start with WebGL. So building 3D into the web, it's not as trivial as it might first sound. We have the native APIs. WebGL, which I'm sure most people know, is a JavaScript binding into the underlying OpenGL and OpenGL, yes. You have the spec, job done. Okay, great, thank you. But it's actually a lot more involved than that, because it's the web. It has to be secure. It has to enable content, the same content, to run everywhere without any tweaks that native developers are often having to do to get their apps to run across different platforms. So there's a number of things that we have to do to WebGL that we go above and beyond the native APIs. The first, in the WebGL working group, is we do runtime checks to make sure the shaders and the programs are valid, and we have some language restrictions to make sure that things don't go rogue. There's a lot of work between the WebGL guys, which are primarily the browser vendors, and the native API guys, which are primarily the silicon vendors, to actually bring up the level of the native APIs to support the security and portability that we need in the web. So there's been a lot of bug fixing and reporting, and we're actually now beginning to find that the native APIs have more functionality to support WebGL. And then in the longer term, you're going to find that WebGL is a good gravitational pull to things like multitasking, preemptive multitasking in the graphics silicon. It'll roll out over time. One of the primary drivers now is providing a seamless end user experience in the browser with WebGL. So the browser land and GPU land are kind of coming together, working hard together to make this platform a reality. And although it sounds kind of boring, it's actually not, because bug reporting and fixing is one of the major milestones that we've met. We are now able to ship fully compliant WebGL 1.0.1 implementations. The browser vendors and the GPU vendors have been whacking away at the bugs and platform issues. So now we actually have, really for the first time in the industry, a reliable platform that can be fully conformant across multiple platforms on desktop and mobile to enable truly portable 3D content. So we're announcing Chrome 25 on Mac, Linux and Windows, and Firefox 19 is on Mac, Linux and Windows as well, fully compliant for the first time. NVIDIA are going to show later, hopefully, the Wi-Fi works. A mobile Android browser is also fully compliant with WebGL 1.01. And there's going to be a bunch of others going to follow any moment now. And there's a bunch of people to thank. AMD, Intel, NVIDIA, the Chrome team, the Firefox team, the Safari team, Mesa. Everyone's going to be pitching in to make this a reality. It is, although it's bug fixing, it's a major milestone in portability. The other announcement we're making with WebGL is where we have the WebGL 102 spec in ratification. We're expecting to formally release this at the end of April. Though WebGL does most of its spec development in the open, so you can actually go and check it out if you want, but it's going to be formalized at the end of April. It's a minor number update because we're not adding significant new functionality. We're continuing this theme of portability, reliability, and precision in what the specification says. A whole raft of changes to where we've had a little bit of ambiguity in the previous spec. We've tightened it down just to make sure that the content that uses WebGL can really run across many different platforms. And last but not least, the conformance tests. Of course, the conformance tests are a key part of any spec. We've actually upped the number of conformance tests from 8,900 to over 21,000. There's a whole bunch of effort has gone into conformance testing. And Greg Tavares at Google and the OpenGL ES working group, again, the browser guys and the GPU guys coming together to make this a reality. But we do have some new functionality too. There's a small selection of new WebGL extensions that are also going to be released at the end of April. Some extra functionality from the OpenGL ES2 ecosystem, but also, again, reliability. What happens if you lose a context because someone turns off the phone in the middle of a WebGL application running in the browser? Well, we're beginning to define how the API would handle that kind of situation. The other big piece of tangible news that we have here, we're going to be putting out the press release tomorrow morning, is Colada is now an ISO standard. Colada, if you're not aware, is a 3D asset interchange format for 3D authoring. It's an XML-based file format that lets you take assets from one tool and into another, round and round, so you can build the virtual tool chain that you need using a pipeline of different software. It's by the SC4 group, TC184, in ISO, which actually is the CAD group, but it's a format that's designed just as much as gamers as the CAD community, and this gives like the long-term stamp of approval. Colada and the ISO version are not going anywhere, so people who want to use Colada for long-term archival of assets can be assured that Colada is going to be here to stay. The Colada's had some issues though in the market because the import and export of assets to and from key tools has not been as robust as it needs to be to make Colada a reliable file format. So actually here last year we agreed with the Colada community how we were going to fix that. We agreed we were going to put a bunch of effort into the OpenColada, which is an open source project for high quality, full function Colada import export. So we're proud to announce that we now have that fully debugged, as far as we know, and uploaded onto GitHub, along with the performance test suite, which is an extensive test suite, also uploaded onto GitHub in open source, available free of charge. So there's no longer any excuse for a tools vendor to have anything less than fully performant Colada IO. And if there are any tools vendors here, come see me afterwards and we'll get you set up with the OpenColada import exporter. The last thing I want to mention is the new initiative. 3D needs a transmission format. It's not fair. 3D is the last media type that doesn't have a widespread codec. Audio has MP3, and you enable a widespread codec with these media types, and unexpected things happen. MP3s, you get Napster. H.264, you get YouTube. And 3D is yet to have its social moment. It's because streaming and compressing 3D is a more complex task than the simple use cases you can have for audio and video. So we are putting together a runtime format. We need this because Colada, as I mentioned before, is not a runtime format. Colada is unashamedly a authoring format. It's big, it's verbose, it's very human readable, which is exactly what you want at authoring, but people are putting a lot of effort into taking their Colada or other asset files, conditioning them, and ready for runtime execution. Everyone's creating their own custom formats, essentially. And it means that, at least for certain markets, we're losing the opportunity to have standardized format for content. We can't do optimized codecs. We can't reuse the content, particularly in the WebGL universe. And we can't have size optimized standard repositories and stores. So GLTF is this final stage format. Is designed to be processed for display by any of the WebGL APIs with very little or no processing. We're using JSON to describe the node hierarchy, so it's web friendly, but it's also will run across many different platforms. And we've taken the decision to split out the binary assets, the textures, the meshes, and the shaders into binary payloads. So we, in the future, can bring compression and streaming technology to bear on those payloads. So we're going to be building this out over the next few months. This is going to be driven by the Colada working group inside Khronos because it is so tightly related. We actually have a prototype implementation of a Colada to GLTF already in place. Fabrice and Patrick, who are here in the audience, have been working on this. It's up on GitHub in open source. So if you have questions, those guys will be able to tell you whatever you need to know. But we do recognize this is probably the first step. We see there's probably at least 3 steps to a full 3D compression solution. Having the node hierarchy from JSON is the first step. Probably using REST to let clients and servers negotiate how they want their 3D assets to be served as a web service is probably the second step. And third, we're going to be working with industry bodies around the world to bring compression technology to bear on those asset payloads. So that was my talk. I think we'll take QA at the end, so just for time. So I want to hand over to Rich from Valve, who's going to be talking about OpenGL.
Hey, thank you, Neil. Next we have Rich Eldridge from Valve. As Neil mentioned, who's going to be talking a little bit about OpenGL and HTML5, I believe, and just gaming developers' perspective on graphics technology.
Thank you. Thank you very much for inviting us, Duke. So, my name is Rich Eldridge. I'm a software engineer at Valve Software. I'd like to personally thank a lot of people in this room who've actually helped us on this effort. So we've got engineers from Intel, NVIDIA, and AMD here that were like involved in this in our cabal room at the same time that I was there. So I'm gonna rush a little bit. I mean, have about 10 minutes. We started a Linux effort last year. It was just a couple people, just Mike Starton and I, and one other person actually, 3 people. And we started with a build that the Steam team at Valve got working. They did an awesome effort to get an OS X and Win32 build merged and then kind of working on Linux. It was only running at around 6 frames a second. It didn't have a bunch of work that was needed to actually ship it. So we did that. And one really important thing that I wanted to get across is some of the reasons for porting to Linux. So the first thing was we saw this trend occurring with OS X and Windows Metro. And it was kind of scary to us that in a long-term perspective, we see these platforms could be closing, and we've built an entire business around an open platform, and a lot of our customers love open platforms too. So we saw this trend that's coming down the pike, so we figured we'd make an investment in this open platform, not just for business reasons, but just because we're engineers, and we want to rally around something that's relatively stable, and will be stable and be available 5 or 10 years from now. We wanted to get hands-on experience with Linux too. We didn't want to go to partners and say, hey, port to Linux, and have them ask, well, that sounds really tough. What have you learned? And we didn't want to have to say, well, we don't know anything about it. So we've been putting a big investment in figuring out the tool situation, the profilers, debuggers, editors, IDEs, etc. And the other thing is really important is that Linux's potential get-out-of-jail-free card. So I'm quoting someone there about that. So if Windows keeps on going in the direction that it's going, a lot of our customers, a lot of our needs and our customers' needs are not aligned with where Windows is going, unfortunately. And we hope that it fixes itself in Windows 9 or whatever, but just in case, we've got that. So we began with Left 4 Dead 2 and Team Fortress 2. And we spoke a lot about that last year publicly on our blog and at SIGGRAPH. We worked really, really hard to make sure that the Linux version of both of those titles would be just as good, if not better, than the Windows versions. So there's a lot of ways of measuring better, and from my axis personally, one axis for me personally is performance or customers' value per dollar on their systems. We wanted to extract as much performance as possible. So we got to the point where we were roughly 10 to 20% faster in GL under Windows, apples to apples, versus our D3D port, our D3D version of our title. And we kind of stopped there. But what was really interesting is that putting that aside, the Linux version of our games on the same hardware was 10 to 15% faster too, repeatedly. So we thought that was really interesting. And we kind of gave up. We could have went faster. So GL is something I'm very passionate about. I kind of skipped 11, D3D 11. I spent 13 years of my life working in D3D on Xbox and under Windows, and you know, I'm really happy that GL came along. GL to me personally is more like a console API. I'm much closer to hardware. I have one less blob of code that's intercepting everything I'm doing. So the video or graphics API is the highest bandwidth channel that our games have to communicate to customers. So, you know, having one less layer in there is awesome. Another thing I realized about 6 months into this effort is, from my perspective, D3D is a dead-end API. GL gets us to mobile. GL gets us with the same investment in Linux, OS X, and Windows. It makes a lot more sense to invest in GL and to reorient our world around GL, and then look at D3D as something that we port to, or like a console platform. So before we would only think about D3D, and then we'd have another team or someone later on that would port to GL, and it was kind of maybe a second-class effort. Well, we've reoriented that and realized that's actually not the equation that makes a lot of sense. Let's just reorient around GL, and then if we have to, port to D3D later on, or translate to D3D. What's really neat about GL is that hardware features are exposed not by OS releases. So in GL, there's a really powerful extension mechanism. We've asked the vendor for an extension, and within 1 week, we've gotten it. Just in the last couple of years alone, I think there's more than 100 extensions. It's pretty incredible. What's also interesting, when I talk to other developers at Valve about OpenGL and D3D, and they're not like so cognizant of the fine-grained differences and stuff, once they understand that features are not exposed by OS releases, so for example, in D3D 11, you gain access to most of today's modern hardware, but you only can ship a D3D 11 title under Windows 7 or later. Well, graphics programmers before, when they only had D3D 9 and 11, they had to have a fallback for their shaders, for their techniques. It was a scalability problem. Well, now, wait a second. If 9 is out of the equation, we only have D3D 11 and GL at most to deal with. We don't actually have to worry so much about the constraints imposed by D3D itself. So OpenGL is a public standard. So we can go to OpenGL.org. We can read in incredible detail the same documents that the driver writers are reading. And that is really awesome because we know, like, we all can talk. Driver writers and game developers can talk with a common language. And OpenGL is not standing still either. So the GPU industry is moving very quickly. D3D is not. It's relatively stagnant at this point. GL is not staying anywhere. So it continues to evolve. But we've been really amazed. We can talk and work with driver guys directly and ask them about the good path, the fast pathways inside of GL, and get feedback from them, and we can give feedback to them. It's really, really cool. So on some of these slides here, okay, I have this kiddie pool API. This was my personal reminder to mention that, you know, I realized 6 weeks, or actually 6 months into this process, after working with NVIDIA and AMD and Intel, like I'm able to work and talk with engineers who have not worked in GL for 5 years or 10 years, some of them for 15 or 20 years. So these are the experts in graphics. I've never had that ever happen with D3D. So I kind of look at GL as the kiddie pool API, and now I've left that, and now I'm in the deep end. So here's some screenshots real fast of the GL version of TF2. I have a couple in here, running in Ubuntu Linux. And these are customer screenshots, actually. I got rid of the customer's email address. So we have the Steam client, which was released publicly on February 14th. And real fast about Steam, I heard a lot of numbers tossed around earlier. We have 50 million customers with value in their Steam account at this point. When I came on board Valve 3 years ago, we only had roughly 25 million, so the growth has been incredible. Any day at noon, we have roughly 6 million active connections, or 6 million players. The growth last year, we had 50% growth. It's just explosive and it continues, so it's pretty amazing. So the Steam client is now available for Linux. There's also available for OS X and Windows. So the path from here, so we can continue to expand our footprint internally, and basically our expertise and our knowledge in GL. So last year it was pretty much just me, and I frankly was starting from scratch. I knew a lot about D3D and GPUs, but not much about GL. Now we have probably 5 or 6 people internally. Their whole careers now are kind of aligned around how do we make sure that all of our titles have first-class GL support. We've been working really closely with vendors on their debugging tools. So we basically have scoured the internet for every open source tool we could find and looked at all the vendors' proprietary tools and just installed them and tried them out. And any problems that we had, we would email the vendor and get a dialogue going and get them working. So at this point, compared to last year, we have probably quadrupled the amount of tools that we can use internally on our very large-scale GL apps. So this is pretty technical. I wasn't really sure if anybody was interested. Internally, we're actually modifying a really useful open source tool named API Trace. And so we're going to add some key features to that. And this tool is not designed, at least from our perspective, to supplement the proprietary vendor tools, but to kind of augment and amplify what we can do with those tools. So anyway, I'm involved with some other presentations here, and if you want to see like more technical information about the thing we've done last year, go to them, and if they have any questions, let me know.
Next up, Neil Trevitt is going to give us a demo of WebGL on mobile. And the neat thing about this, of course, is that while this is a demo of WebGL on mobile, the WebGL application itself will run on any platform where there is a WebGL enabled browser. So it runs in the browser on any platform that's platform independent.
So I just really want to wrap up what Rich was saying and what Matt was saying earlier. Just kind of perhaps throw some thoughts out there to inspire some Q&As and discussion afterwards. You know, the OpenGL family of APIs is really becoming the API that you can run everywhere. We've just been talking about desktop and Linux, the fact that OpenGL is delivering the functionality and performance that we need there. In mobile, OpenGL ES is probably shipping on 98% of mobile systems. It's really Android, iOS, BlackBerry, Ubuntu, everything is running OpenGL ES. And then this last piece, bringing 3D to the web. So WebGL, in terms of its deployment, it's running on most desktops today, and I think it's this year is going to be where we do see WebGL begin to roll out in a fully performant way across mobile. So it's going to be the interesting 12 months. And of course WebGL in the browser as part of HTML5 is kind of, it reaches everywhere. It reaches back into mobile and desktop. It's another way to run 3D content that can be updated and downloaded in real time from the net. It's going to be used in cars. It's going to be used as a portability tool to get not just onto the high-end smartphones, but onto every phone that supports an HTML5 browser. It's going to be used on TVs. It's going to be used basically everywhere. So OpenGL and the family of APIs is enabling the 3D market in a bunch of different places. So, in theory, and I just wanted to show the demo because it is a relevant demonstration. So this is a mobile device. Happens to be the NVIDIA Tegra 4, but there's going to be a bunch more coming any moment now. And this is, I'm sure most of you recognize it, this is the Unigine game engine port running. This is a web page. It's not an application. It's not a native application. It's a web page. So this is the kind of interactivity and quality that the OpenGL family of APIs is going to be able to provide in web pages across any device in a portable, robust, secure way, starting now. So it's an interesting time for the 3D industry. That's it.
Thank you, Neil.
For being polite.
Okay. Thank you everyone for coming, and thank you Ted Pollack from JPR, Matt Playar from Intel, Neil Trevitt from NVIDIA, and Rich Gildrish from Valve. Sorry, I have trouble remembering your last name, Rich. I also have a complicated last name, so I'm used to it. But we have some door prizes here for those of you who left your business card and took a coupon.
It's on the bar.
And we're bringing that up.
Next one then.
That's crazy. 524.
524. All right.
I was worried. I know how to work. So come up here. So you get to pick whatever you want. We'll keep your first choice, and there's shopping bags over here. I've got to point some of this out. We have 1994 vintage Franklin mint. This is three-dimensional Star Trek chest. We've got, it comes with pieces that are actually gold and silver plated. We have boxes to get all this home. We've got vintage Lara Croft toys. We've got Star Trek models. We've got wonderful Logitech gaming mice and keyboards, and then all kinds of t-shirts from the different organizations. Really nice silk polo shirts. So, and then the glass sets. And I've got boxes to get everything home. So here, you pick and I'll keep rolling.
And yes, 1996 is vintage now.
Of course it is.